For decades, physicists have been wrestling with one of the biggest questions out there. What is the universe actually made of? We've been told that a staggering 95% of it is just a complete mystery. Well, today, we're going to dive into a pretty radical new answer, one that suggests the universe isn't missing anything at all.
So this is the picture you've probably seen before. Everything we know, everything we can touch and see, stars, galaxies, us, that's all in that tiny 5% slice called ordinary matter. The rest of it, a whopping 95%, is this enormous question mark, which we've labeled dark matter and dark energy.
95%. Just let that number sink in. It basically means our best, most fundamental theories of physics are completely in the dark, unable to explain what the vast majority of our own cosmos is.
But what if we've been looking at this all wrong? What if we've been asking the wrong question? What if that 95% isn't some invisible, mysterious stuff, but it's actually just an illusion, an artifact created by the way we observe the universe?
Okay, so to really get our heads around this, we need to explore a totally new way of thinking, a new framework. And it all starts by challenging our most basic idea of what reality even is. So, the huge insight from this new theory is this. Reality isn't just a collection of little separate things like particles. It's a continuous geometric process. The theory is saying, hey, instead of asking, what is the universe made of, maybe we should be asking, how does the universe work? And the answer it gives is that everything, and I mean everything, from a single photon of light to a whole galaxy, pops out of one single repeating pattern. I want you to picture a tiny self-sustaining whirlpool of pure energy. This theory suggests that this simple geometric pattern is literally the fundamental building block of our entire universe.
Okay, so if everything is made from the same basic pattern, why does the universe look so incredibly different at different sizes? Why is a galaxy nothing like an atom? Well, the theory's answer is that it all comes down to the scale you're observing it from.
This framework organizes reality into this really neat hierarchy of different scales. And here's the fascinating part. Our own viewpoint, what's labeled here as the human scale, it's just one level on this massive cosmic ladder. It's not special, it's not a privileged position, it's just our position. And where we happen to be standing fundamentally changes what we're able to see. So how do we actually connect these different scales? How can we translate what's happening way down at the quantum level to what we see way up at the galactic level? Well, the theory gives us a mathematical tool to do just that, and it's called the universal projection law. Now, hey, don't get hung up on the math here. The core idea is actually incredibly simple. What we observe is never the absolute unfiltered truth. It's always a projection, kind of like a perspective. Think about a 3D sphere casting a 2D circle for a shadow. That shadow is totally real, right? You can measure it, but it isn't the whole picture. The projection law is basically saying that all our scientific measurements are like that shadow, a real but incomplete view of a much deeper geometric reality. So think of it this way. On one hand, you've got the intrinsic reality, the pure underlying geometric pattern of a thing. And on the other hand, you have the observed reality, what our instruments actually pick up and measure. According to this theory, the difference between those two isn't some mistake. It's a predictable, totally unavoidable consequence of observation itself. All right, so how on earth does some law about observation solve the biggest puzzle in cosmology? How does this get us back to dark matter and dark energy? Well, this is where it all clicks into place. So the projection law actually predicts that if you go and measure the mass of a galaxy using two different methods, you're guaranteed to get two different answers. Why? Because each method is a different kind of shadow. Now, astronomers have seen this exact mismatch for years, and they explained it by just inventing missing dark matter to make the math work out.
And this right here shows the theory's power. Using real data from a massive survey of galaxy clusters, the theory predicts that the ratio between two different ways of measuring mass should be 0.961. And the actual observed value from the astronomers, 0.962. That is an almost perfect match. The so-called missing mass isn't missing at all. It's just the predictable geometric distortion, the projection, that the theory perfectly accounts for.
So the theory explains dark matter as a projection.
But what about dark energy? That mysterious force that's supposedly pushing the universe apart faster and faster. Well, the theory treats this in the exact same way, not as some weird energy, but as another predictable effect of our cosmic point of view.
At its deepest, most fundamental level, the theory says the universe is actually in a state of perfect geometric balance. But, and here's the key, when we observe that perfectly balanced state from our particular scale, the human scale, the projection law says it has to look like accelerated expansion to us. The acceleration isn't really happening out there, it's an artifact of where we're looking from.
This quote from the source paper really just sums it all up perfectly. What we've been calling the dark sector is simply the geometric shadow cast by observing reality from a different scale than its own. It's not hidden matter, it's just geometry. So, if this whole framework holds up, the implications are, well, they're huge. It would force us to completely rethink some of our most basic ideas about the universe.
The biggest takeaway is this. There is no dark or missing stuff. The universe is whole. We just see parts of it as shadows because of our perspective. This idea could potentially unify physics under a single geometric rule, and most importantly, it makes new predictions that we can actually go out and test to see if it's right or wrong.
And just how deep does this geometric model go? Well, check out this number, 137.036. This is the inverse of the fine structure constant, one of the most fundamental and seemingly random numbers in all of physics. It governs how light and matter interact. This new theory actually claims to derive this constant straight from its core geometry. It's suggesting that the very laws of physics aren't random at all, but are woven directly into the geometric fabric of reality itself.
And that, of course, leaves us with one last really profound question. If the single biggest mystery in modern cosmology turns out to be nothing more than a trick of perspective, what else are we misinterpreting? What other parts of our reality are just shadows cast by a deeper geometry that we are only just beginning to understand?